Close your eyes and breathe slowly. Tonight we tell a story that lives between circuits and starlight, a gentle tale that unfolds in 1 week when the world hesitated, when machines and stars both turned away. It begins with an ordinary night and then asks you to imagine the extraordinary. On a morning in October, the internet stilled. Phones that always sang with messages fell silent. Apps that responded like friends stopped answering. A data center in Virginia, the slow pulsing heart of so much human chatter, went dark as if someone had covered the planet's mouth. For hours, billions of small, constant connections that stitch our days together were not there. People sat with empty screens and found, to their surprise, an unfamiliar quiet at the center of their lives. While technicians in windowless rooms traced failures and rebooted the machines we treat as invisible infrastructure, astronomers in glass observatories watched something else disappear. An interstellar visitor named 3I divided by Atlas, slipping behind the Sunday. This was no ordinary comet. It arrived from another star, carrying the slow history of distant light. Scientists had tracked it with care, measuring its angle, its speed, the pale chemistry of its light. They called it a messenger from elsewhere, a fragment carrying stories older than our own sky. And then, as the world wrestled with a collapsing network, the visitor met the sun's glare and was lost to our instruments. For a time that felt like a held breath, Earthbound watchers had neither network nor sky. 2 blind spots opened in the same week, one in code, one in light. People whispered coincidence. Engineers spoke of cascading failures and overloaded systems. Astronomers explained that solar conjunction steals sight and that physics keeps its distance. But the coincidence felt like a mirror placed between the human and the cosmic. It asked whether we had created fragile things, and whether, for a few nights, both the sky and our inventions could step back and show us what we had taken for granted. So lean back into your pillow and let the details settle like soft dust. In the data centers, machines that route names to numbers, the DNS servers, began to fail. Monitoring tools that supervise other tools went blind. Databases became unreachable like rooms with locked doors. The architecture that makes countless invisible decisions every second suddenly found itself without a map. Services based on these hidden protocols faltered. Voices paused, ledgers stopped updating, animations froze in mid-motion. Those working inside the centers felt a peculiar helplessness. Their instruments could not instrument themselves. They became listeners to a silence they could not measure. On the other side of the world, telescopes trained on a streak of light captured the comet's fine smoke and faint minerals, its peculiar chemistry that did not quite match familiar icy travelers. It showed traces of metals and gases in patterns that teased questions about its origin. How a fragment shaped in another home star's cradle might carry unexpected alloys and volatiles. A comet like that promises revelations. It is a messenger body, a geological postcard. And then the postcard passes behind the sun's brightness, and those pages become unreadable. In that darkness, the comet might have warmed, fractured, shed material. It might have adopted a new shape, a new voice, and yet for days we could not know. Across forums and cafes and late-night threads, people constructed small mythologies to lighten their unease. Some imagined a hacker hiding behind the cosmic event, timing chaos to the moment when our focus would tilt sunward. Others pictured a strategic actor watching calendars and counting on our disbelief. The human mind is a storyteller by habit. It seeks pattern in the overlap, and still, most experts return to grounded explanations. Centralized infrastructure, human error, the stubborn gravity of networks dependent on single geographies. But this story, held gently now between your hands, is less about proving conspiracy than about noticing fragility. Months before, cables on the ocean floor had shown us how physical our virtual world actually is. Submarine fibers carry the hum of nations and can snap under anchors or be disturbed by storms and earthquakes. Earlier that year, a solar outburst had flirted with catastrophe. A coronal ejection roared from the sun and missed Earth by a narrow tilt, a near miss that reminded the world of how small margins hold big systems together. Another incident had silenced sophisticated artificial minds for hours, exposing how dependent businesses and caregivers had become on synthetic voices. All these events wove a pattern, a fragile lattice where a single break could ripple into a global pause. When 3i, divided by Atlas, disappeared behind the sun, it took with it a small, stubborn hope of direct knowledge. Scientists yearn for continuous observation. Gaps that the sun enforces are gaps that might hide transformation. Perhaps the comet lost mass and shed dust into a tail the size of cities. Perhaps it flared and altered its path. Perhaps it simply passed, indifferent. When it re-emerged, telescopes would answer some questions, but not the ones for that dark interval. The world that woke from the outage carried a new awareness. There was a strange gratitude for the hum of devices that had before been invisible burdens, and a simultaneous unease at how dependent life had grown on unseen scaffolding. In bedrooms where phones were silent, people noticed small sounds, distant traffic, the creak of a refrigerator, a neighbor's laughter. Tiny things, easily drowned by constant notification chimes, found room to be noticed. At the same time, the scientists who watched the sky felt the hollowness of an observation gap. The universe keeps no diary for us. If we miss a moment because sunlight blinds our instruments, that fragment is gone to human record. Over weeks, teams pieced together forensic timelines and observational logs. Networks were restarted and patched, cables rerouted and checks implemented. The comet's afterglow returned to charts and spectra, and astronomers compared notes about subtle differences in brightness and composition. The public kept asking a simple question: could anything from the void touch our wired world? Physicists smiled the careful smile of deferment and explained distances, fields, and energies. The sun's light could not tug at a server rack in Virginia, and a comet many millions of miles away could not flip a router. And yet, in the hush that followed, a more human answer took hold. Nothing needed to touch us for the event to matter. The overlap had been enough to make us look inward. Maybe that is the real lesson of the week. The cosmos and our constructions share a border where human perception happens. When both sides darken, we are left to learn how dependent we are on light and on lines of code. The comet's return weeks later offered a quiet epilogue. 3i divided by Atlas emerged as a softer presence, its tail suggesting it had been altered by heat, its spectral lines carrying evidence of materials shaped by foreign chemistry. Astronomers celebrated small triumphs, refined orbits, a deeper sense of origin, but the memory of silence persisted. Engineers rewired processes, built more resilient paths, and imagined systems that could fail gracefully. Communities discussed contingency, backups for more than data, for communication, and for the human routines that depend on it. And still, when night fell afterward, a subtle tenderness remained in the air. People imagined the sky as a room full of visitors, some passing quickly, others lingering. They imagined their devices as fragile lights in a larger dark. Tonight, as you settle, imagine those two blind spots, not as threats, but as teachers. Feel the smallness and the wonder that come with understanding how precarious connection can be. Let the fact that the world and the sky pause together be a soothing reminder. Even grand systems take breaths. Perhaps there is comfort in knowing that silence can reset us, that a week without the relentless hum can widen space for noticing. Perhaps there is a lesson about humility, that our reach into the universe is still young, that we are learning to keep watch with limited eyes. In the hush that follows every blackout and every skyward blackout, a question remains soft and patient. What will we do with the knowledge that our web is delicate? Will we build redundancies that mirror the complexity of life, or will we continue to thread everything through a few thin tunnels? Those choices will shape future nights. For now, breathe slowly and think of a pale fragment leaning into the sun, of server rooms where lights came back on, of people who found unexpected quiet in the spaces where their phones used to be loud. Sleep with the image of a world that paused and then resumed, a little wiser for the interruption. Know that the stars continue their passage, and that our networks will hum again, but with a gentler understanding of their place in the dark. Let this story be a soft lullaby, a reminder that even in silence there is company, that blind spots are invitations to look inward, and that the cosmos, in its cold grandeur, can fold space and time into lessons for our fragile, splendid lives. In the days that followed, small rituals returned like tides. People learned once again to wait for answers rather than demand immediate confirmation. They rediscovered patience, calling a friend and listening until the line breathed, reading a page until the margins blurred with sleep, looking up at the night and letting the stars happen instead of photographing them. Communities gathered to talk about contingency with a newfound seriousness that felt reverent rather than fearful. Local libraries extended hours, neighborhood centers set up notice boards. Elders taught how to keep paper records and how to share news by voice, by human chain, when glass fails. Engineers, exhausted and precise, filled whiteboards with diagrams that tried to imagine a network without a single beating heart. They argued about geography and policy, about whether redundancy should mean multiple continents or 1,000 smaller nodes. A teenage coder in Jakarta sketched out a vision for a mesh network that could bypass centralized regions. An old technician in Virginia, hands flavored with oil and light, remembered days when systems were simple and manual, and he lobbied for more human-readable logs. Astronomers, too, rewired their expectations. Observatories coordinated more international observation windows. Radio arrays practiced listening in tandem with optical telescopes. Amateurs with backyard scopes were encouraged to share raw footage to catch moments professional arrays might miss. Scientists composed new plans for catching the next interstellar whisper. Instrument arrays that could observe the sunlit side indirectly. Relay stations placed at Lagrange points. A ballet of satellites that promised fewer blind intervals. In coffee shops and on late-night radio, people spoke of wonder. The comet became a small myth, a reminder of distance and continuity, of the fact that we are not alone in moving through a universe that does not revolve around our convenience. Poets wrote about the week the world went silent, comparing the outage to an old wind that clears dust from a room. Musicians composed long, slow pieces that imitated the dead pause and the gentle reintroduction of sound. Mothers told children a bedtime version of the event, a soft parable about a tiny traveler who got too close to the sun and needed to hide behind its bright skirts for a while. In these retellings, the comet was kinder, full of mystery and mercy. Through it all, a subtle policy conversation emerged about how much society ought to let critical infrastructure consolidate. It was uncomfortable. It touched on profit and efficiency, and the invisible trade-offs of convenience. Yet it was also practical. Planners discussed staggered deployment, more fiber routes, and incentives for distributed cloud alternatives. Years later, the week remained a touchstone. When systems failed in minor ways, people compared the pause to that October silence and asked whether new designs honored the lesson. Schools taught modules on the physicality of the internet, mixing geology and computer science. so that future engineers would remember cables on the sea as well as code in the cloud. In quiet moments, astronauts on the International Space Station looked toward the horizon and thought about tiny visitors that cross between stars. They felt a kinship with the transient, with the idea that even structures as carefully maintained as orbital platforms can meet moments that are beyond prediction. And somewhere, tucked into the memory of this episode, was humility, a realization that mastery is always partial. For all our dashboards and sensors and blooming arrays of data, there remains an irreducible sliver of the unknown. We can reduce it, narrow it, but perhaps never erase it. Remember the dates, October 20th and October 21st, 2025. Remember the hush in time. It is useful to keep precise anchors because memory is a landscape made of small pebbles and named stones. On those nights, people learn that the pulse of daily life is a composite beat made of tiny technical heartbeats. A cashier's terminal that could not reach the ledger, a doctor delayed in retrieving a record, a message that arrived hours late. These were small disturbances, but they added up into a world briefly rearranged. Consider the smell of a server room after power cycles and human hands work through the night. A metallic ozone tang, the warmth of machines exhaling, the faint scent of coffee and focused exhaustion. Those small sensory details tether the abstract idea of an outage to human bodies working in fluorescent-lit rooms. Consider the cold brightness of a telescope dome at dawn, instruments slanting toward a faint smear of light, astronomers wrapped in scarves against the chill. They check collimators, tighten fittings, and whisper to each other as if the comet were a sleeping child to be checked without waking. This story is also about small kindnesses. A neighbor lending a flashlight, a barista offering a phone to make a call, an older person explaining how to keep records without relying on a cloud. Those actions are the quiet scaffolding that supports resilience. From policy rooms to kitchen tables, conversations began about designing systems for the long view. How do we plan for the eventuality of silence? How do we multiply sources of light so that when one goes out, others remain to guide us? Engineers proposed decentralized caches that could operate locally for hours or days. City planners mentioned analog backups for critical services. Educators suggested simple curricula that taught children to send messages by paper and to navigate without constant confirmation of location. A gentle, almost tender cultural shift occurred, a move away from the tyrant of immediate response toward an acceptance that some things can wait and that waiting can be a form of respect. And yet, despite the lessons, life resumed its usual acceleration. Notifications returned, algorithms re-engaged, and the world went back to its old tempo. But there is a residue to such moments, a quiet skepticism, a new whisper of caution in system design meetings, a poem scrawled in margins that remembers the week networks slept. Think of nights like this as small clearing storms, where the sky opens a little and we see the scaffolding. The comet, cold and indifferent, moved along its ancient trajectory. The outage, human and rectifiable, demanded technical humility. Both events converged into a single gentle demand that we pay attention to the seams. By the time the comet returned to full view, cameras and spectrographs painted a picture richer than before. The traveler had been warmed. Its surface chemistry bore subtle changes. The data did not conclude a conspiracy, nor did it produce a grand revelation. Instead, it handed us quiet facts that are the bricks of knowledge: shifted brightness, altered tail morphology, and a few spectral hints of metals uncommon in typical solar comets. In lecture halls and late-night chats, people debated whether we had missed a message the universe had tried to send. The more patient answer was that the universe rarely sends messages to order. It offers phenomena, and we interpret them with the tools at hand. Sometimes our tools are asleep, and the phenomena continue anyway. So tonight, let this story be less about fear and more about caretaking. Imagine engineers as gardeners tending networks, astronomers as night watchpersons tending a fragile sky, and yourself as a gentle observer, learning to relish silence as much as sound. Let the comet be a lullaby of distance and the outage a chorus of domestic proximity. They are two notes in the music of our age, one reminding us of how far we can look, the other of how close we are to the systems we rely on. Now, breathe slowly. Allow images of slow-moving light and warm server rooms to settle. Hear the small sounds, the distant washing of a neighbor's roof, an engine humming, your own breath moving in the dark. These are the textures of continuity. When you awaken, there will be new data, new measures, and perhaps new policies. But for this night, accept the pause. Let the silence that once frightened become a space where you practice listening. Feel the ease of leaving a device unlit and the quiet luxury of not knowing for a little while. In the long story of humanity, these are but small pages. Yet sometimes small pages turn into chapters. The week the world went silent will be remembered for practical changes, yes, but also for how it taught a global public the ancient craft of waiting. Sleep now, under the patient sky. Imagine the comet following its long road through the dark, a tiny ship crossing the ocean of stars, and imagine our lights below, fragile but stubborn, pulsing back into life with care. Rest, knowing that silence can teach, and that the next morning will come with both new questions and renewed resolve. In this hush, remember the tender fact that we are still learning to be citizens of a large and indifferent cosmos. Be kind to the small things that keep your world running and curious about the vast ones that do not obey our clocks. Carry tonight's quiet as a small talisman. Practice patience, design generosity into your systems, and let wonder sit beside your worries. Let the silence be a blanket that comforts rather than a shroud that frightens. Let your dreams be of small lights reappearing in the dark, one by one, as if each were a star regaining its voice. Rest now. In the morning the networks will hum and the telescopes will make new measures, and life will continue kinder, perhaps wiser, perhaps, still under the same grand, unblinking sky. Tomorrow the world will speak again. Tonight, let silence teach us. All right, the next story we settle into is about deep time, the faint hum of cosmic interconnection, and a mystery that only began to unfold when everything in the outer solar system aligned in a way no physicist thought possible. This is the tale of Project Lachesis and the unsettling whispers carried on the solar wind during the solstice of Eridanus. Part 1. The arrival of the rogue shepherd. In the cold, perpetual darkness that lies beyond the Kuiper Belt, past the final, lonely sentinels of ice and rock, a celestial body was moving. It wasn't a comet, pulled by the sun's fierce gravity. It wasn't a Kuiper Belt object, tethered to the ecliptic plane. It was an object catalogued as Xylos, a rogue exoplanet, roughly the mass of Mars, traveling on an impossibly shallow hyperbolic trajectory that was bringing it into our Oort cloud, yet not towards our Sunday. Imagine the Oort cloud, that vast spherical shell of icy debris as the very edge of our sun's dominion, a shimmering, silent boundary between the known and the interstellar void. For millennia, it has remained undisturbed, a frozen record of the solar system's birth. But Xylos, this quiet, dense traveler, was slicing through it like a ghost ship through heavy mist. The scientists at Project Lachesis, operating out of a subterranean complex in the Atacama, initially dismissed it as a statistical anomaly. Xylos was too dense to be a captured object, too distant to be a planet, and its velocity was subtly wrong. It was moving too slowly, yet with an inexplicable rotational frequency. Doctor, Elias Thorne, head of the project, often described it to his interns as a silent shepherd, because its passage wasn't causing gravitational chaos. Instead, the distant cometary bodies ahead of it seemed to be settling, their orbits becoming unnaturally orderly, as if drawn into a state of subtle rotational peace. This state of uncanny quietude was the first clue. Gravity, we understand. Chaos, we anticipate. But this induced cosmic order suggested a force that was less about brute mass and more about resonant fields. Xylos was not just moving through space. It was interacting with the fabric of space-time in a way our current models could only vaguely predict, leaving a wake of unnatural stillness in its path. We often forget that space is not empty. It's a plasma-infused medium, a vast electrical conductor. And Xylos seemed to be tuning it. Part 2. The Silence of the Sentinel. Roughly 2 months after Xylos's initial detection, and just as it entered the inner Oort cloud boundary, our attention was wrenched toward the very frontier of interstellar space, Voyager 1. The oldest, loneliest messenger humanity has ever launched, now traveling through the turbulent, magnetically active realm of the interstellar medium. For decades, Voyager's plasma wave subsystem had been sending back a steady, albeit faint, recording of the density and magnetic pressure outside the Sun's influence. It was the sound of space, a low, oscillating hum. Then, at 3:17 UTC on the morning of the solstice, the hum stopped. Not a sudden catastrophic failure, which would have indicated a micrometeorite strike or power loss. Instead, the data stream showed a perfect, complex harmonic spike, a signature so mathematically pure, it initially triggered a data corruption warning. The spike lasted exactly 4.83 seconds, and then the plasma wave detector went dead. Silence. A digital void that stretched for 3 hours before the system miraculously rebooted, only to report normal but inexplicably weakened background noise. Dr. Thorne, a man who rarely used adjectives stronger than noteworthy, called the initial 4.83-second burst a signature of deliberate compression. The energy was not random. It was structured, like a perfect chord struck on a gigantic interstellar string. It suggested that a colossal wave of structured energy, perhaps an extremely low-frequency electromagnetic pulse, had washed over the probe. A wave that carried a pattern, not noise. What was the common thread? Xylos was still hundreds of billions of kilometers away from Voyager, yet the moment of the signal's emission was calculated to have perfectly intersected with the time Xylos crossed a major heliopause boundary relative to the plane of the ecliptic. It was a conjunction of events separated by unimaginable distances, yet connected by a single, terrifying timestamp. Part 3. The geometric veil of Saturn. The third, and perhaps most beautiful piece of the puzzle, appeared orbiting the ringed jewel of the solar system, Saturn. Saturn's rings are a masterpiece of chaos and gravity, billions of particles of ice and dust, constantly colliding, shaped by the push and pull of its many moons. The ring system is dynamic, complex, and utterly predictable under the laws of physics. However, a global amateur astronomy collective, monitoring Saturn's rings for the annual Mimas resonance shift, captured something unprecedented. A new, perfectly defined, faint K-ring had formed in the outer F-ring zone. This ring was not a cloud of particles, it was a structure. It possessed a lattice-like geometry that was visible only under specific infrared spectrums, forming a series of non-Keplerian shapes, squares, tetrahedrons, and perfect hexagons that rotated not by gravitational rules, but by an internal, synchronous frequency. The material forming the K-ring was not typical water ice. Spectroscopic analysis suggested charged silicates infused with rare earth plasma, and its formation was instantaneous, not gradual. It appeared overnight, on the very day the Voyager signal went silent. This geometric construction, defying the mathematics of orbit mechanics, suggested an active manipulation of the magnetic field lines. Saturn is a giant magnetic dynamo. Its rings are essentially vast plasma screens. The K-ring was acting like a colossal circuit board, holding impossible shapes in place through an unseen electromagnetic framework. Thorne theorized it was a triangulation point. The rogue planet Xylos, the charged particle field of the Oort cloud, and the magnetic field of Saturn were not three separate entities. They were nodes in an ancient, forgotten network. Part 4. The inevitable alignment. The ultimate realization lay in the calendar. The solstice of Eridanus. This wasn't a modern alignment. It was an ancient, calculated celestial moment when the center of the Milky Way galaxy, the plane of the solar system, and the most distant star in the Eridanus constellation that the ancients could track, all fell into a near-perfect 33.3-degree angle. This particular angle, according to obscure astronomical texts recovered from a forgotten observatory in the Himalayas, was called the angle of zero entropy, the point where the flow of cosmic energy achieves maximum coherence. Every event that had transpired, the calming field around Xylos, the perfect harmonic spike from Voyager, and the geometric formation of Saturn's K-ring, had been timed not to the modern Julian date, but to this ancient, almost mythic solstice. The hypothesis: what if the solar system, with its planets, its magnetic fields, and its plasma sheaths, was not merely a mechanical clockwork, but a vast, organic, resonating instrument? And what if Xylos wasn't a rogue planet, but a key, a massive, natural tuning fork, designed to enter a specific region of the Oort cloud at a specific time, to induce a coherent magnetic field resonance that would travel through the interstellar medium, strike the Voyager probe at the perfect instant, and finally, activate the solar system's primary magnetic node Saturn to display a geometric signal. The signal wasn't a radio transmission. It wasn't a light pulse. It was a structure. A temporary, perfect architectural arrangement in the plasma of the rings. A message written in the language of pure physics and geometry, lasting only a few weeks until the solstice alignment broke. The whispers carried by the solar wind were not random. They were the gentle hum of this cosmic mechanism coming to life after eons of silence. Epilogue. The deep hum of connection. As we watch the solstice pass and the K-ring slowly dissolves back into the random chaos of Saturn's dust, we are left not with answers, but with a profound sense of awe. The events suggest a vast, interconnected ecology of energy, where the movements of a single rogue body can ripple across light years and awaken ancient, dormant physics. It forces us to reconsider what coincidence truly means in a universe defined by laws we have barely begun to scratch the surface of. Perhaps the greatest lesson from Xylos, Voyager, and Saturn's geometric veil is this: we are not observers in a cold, silent universe. We are living within a massive, intricately wired machine that occasionally, gently, and with infinite patience, sends us a message written in the language of stars and magnetic fields. Rest now. Let your mind drift with the slow, resonant currents of the cosmos. The universe is awake, and its humming is the softest lullaby. Good night. Okay, let's go to the next story. Close your eyes if you like, or keep them softly open. Let them fall into the gentle half-light, where room and sky breathe together. Breathe once, slowly, as if inhaling a secret the universe has been whispering for billions of years. Breathe out. Release the day, like a small stone dropped into a wide, patient pond. Tonight we will walk, softly and carefully, along the edges of wonder. Imagine first a single point of light, far beyond the reach of your fingertips. It hangs in the vast blue-black, a patient ember in the dark, That light is an ancient letter, written in photons and carried for eons across loneliness and time. Each photon is a tiny messenger telling a story of clouds collapsing, of pressure building, of eventual fire. It tells us how a star was born. We begin in a nursery, not of cradles and lullabies, but of dust and quiet gravity. In these vast stellar nurseries, clouds of hydrogen breathe and sigh. They swirl and settle, a slow, graceful choreography. Regions within them grow heavier, tiny seeds of density that call to each other. Gravity, subtle and relentless, draws them closer until warmth blooms in the heart of a contracting cloud. At first, there is only the hush of atoms colliding, but then the hush becomes a murmur, and the murmur a steady hum, the birth heartbeat of a star. Picture that newborn star like a candle cupped against a blizzard, fragile yet defiant. It begins its long work of turning matter into light, forging heavier elements in its crucible. Over millions or billions of years, it is both creator and instrument, carbon, nitrogen, oxygen. These are not gifts dropped from nowhere. They are the labor of stars, the slow alchemy that stitched the periodic table into patterns that would one day be read by biology. Drift now to the patient geometry of planets. The protoplanetary disk that surrounds a young star is a slow-turning carousel. Dust grains stick like shy dancers, finding partners. Pebbles accumulate to rocks, rocks to boulders, and boulders, by a kind of stubborn fortune, become worlds. Each planet falls into its lane, some near and scorched, others distant, wrapped in the deep sleep of frozen gases. Some catch thick atmospheres and wear them like robes. Others are bare, their scarred surfaces reading like old maps. Listen. The language of geology speaks in storms and tides, in continents wandering on oceans of rock, in the patient corrosion of winds. On some worlds, water pools and waits rivers tracing the skin of the planet, oceans breathing with the slow rhythm of tides. Where chemistry and liquid meet, curiosity becomes possible. Where energy is steady and ingredients meet for long enough, chemistry can begin to take the first timid steps toward biology. Life, when it appears, is not an announcement so much as a very quiet persistence. It is the universe learning to know itself through rearranged atoms and the improbable poetry of replication. Let your mind stroll now beyond the pale neighborhood of a single star to the wider assemblies, binary stars that spin around each other in an intimate conversation. Systems where planets chase one another in complex arcs, moons that steal the stage and then return it. Imagine a night sky from the surface of a world that circles two suns. Dawn here and dusk there, shadows overlaying and unraveling, as if the universe were practicing a gentle illusion. Or imagine a planet where the seasons stretch for centuries, and an entire civilization learns patience from a slow, wandering orbit. We can come closer, closer than even the crescent of a moon, and meet comets. Comets are wayfarers, icy, ancient, carrying the scent of the outer reaches. When they approach a star, heat teases their frozen past into jets of dust and gas, creating a tale that points away, like a memory streaming behind a moving soul. Some comets have visited the young Earth, delivering water and organic molecules, small serendipitous couriers, possibly responsible for nudging chemistry toward life. They are reminders of how the universe keeps its treasures in remote vaults until the right moment. Now, allow the scene to widen. The galaxy is not a static painting, but a slow, turning ocean of stars. Our Milky Way is a disk of countless lights, an elegant swirl observed edge-on as a delicate line of soft brightness, or seen from within as a band of spilled sugar across the night. The galaxy's spirals are arms roots of ongoing formation, places where gas is funneled, compressed, and nudged into new generations of stars. At the center sits a quiet storm, a supermassive black hole, not a hungry villain in a storybook sense, but a sculptor whose gravity molds the dance of millions of suns. Black holes are not only endings, they are thresholds. Their gravity warps both space and time, bowing light as if the fabric of reality were a soft sheet. When a black hole feeds, it can make light brighter than entire galaxies, an irony that reminds us how extremes are sometimes necessary to create beauty. Around many black holes, matter swirls in a furious incandescent maelstrom, jets of particles leaping outward like fountains that pierce the dark. The mathematics that describe such objects are both austere and wondrous, a vocabulary where infinity and smallness meet. Think for a moment about the scales we talk about. Atoms to planets, planets to galaxies, galaxies to clusters, and then to the cosmic web. Between galaxy clusters, filaments of gas and dark matter trace a pattern like frost on a window. Dark matter, an invisible presence, holds the web taut, a scaffolding without which galaxies would not gather. Though we cannot see it with our eyes, we sense its gravity by watching things move as if pulled by invisible hands. There is humility in that. Much of what shapes the universe is one step removed from our senses, and yet is no less real. Time itself carries a story. The cosmic microwave background is a faint afterglow of the universe's earliest visible chapter, a whisper from when the universe was just a few 100,000 years old. It is cool now, a mere 2.7 degrees above absolute zero. But it is a map, a photograph of the infant cosmos, with tiny fluctuations that seeded everything that followed. To hold that image in your mind is to understand that even the largest things started as the smallest differences, tiniest ripples that eventually grew into vast structures. Picture the cosmic timeline like an old patient book. The first pages are quick and feverish. Inflation, a sudden stretching that smoothed space like kneading dough. Then atoms formed, light untangled from matter, and a dark age fell long and silent until the first stars lit tiny lamps that pushed back the gloom. Galaxies assembled, merged, and spun off new generations of stars. Planets formed from the debris left in the aftermath of these cosmic negotiations. In this unfolding, humanity appears very late, an afterthought in the second-to-last paragraph, and yet, in the human mind, a universe of meaning ignites. Let us visit one small chapter in which curiosity itself evolves. Consciousness. Somewhere in the long history of Earth, early cells invented a trick replication with variation, and then, over eons, nervous systems learned to sense. Brains are storytellers. They knit signals into patterns and name them. Consciousness is an emergent candle, lit by complexity, sustained by exchange, and flickering with memory. It is in this candlelight that we ask why and how, and in asking, we create narratives that fold the cosmos back onto itself. Imagine now an observer standing at the edge of a cliff beneath a trembling aurora, or a night watchman on a ship gazing at the stars smeared with meteor trails. The same processes that cook the insides of stars also create the copper in your phone camera, the oxygen in your lungs, the metal in a bridge, the calcium in a tooth. These are all descendants of ancient stellar furnaces. There is a soft, almost ineffable intimacy in that. The universe gave us, over long patience, the very elements that make selfhood possible. We can also sense the fragility of home. A planet's atmosphere is a delicate blanket. It can warm gently under a benevolent star and sustain richness, or it can be stripped away by flares and winds, leaving raw stone. Small differences in chemistry, rotation, or magnetic shields can mean the difference between a world teeming with potential and one that remains mute and barren. The history of planets is a study in chance and contingency. Local weather, global catastrophes, rare impacts, the ephemeral vicissitudes that shape long-term trajectories. Turn your attention now to communication across distances. Light is a faithful courier, but it travels at an upper limit. Signals sent across interstellar space take years, centuries, or millennia to arrive. Even at light speed, messages are delayed by the tyranny of scale. If someone on a planet 500 light-years away shouts into the dark, their voice is a letter that will arrive here only 5 centuries from now. That slowness teaches humility and patience to any mind that imagines sending greetings. Consider how we listen. Our instruments extend senses. Radio telescopes tune to the faint hum of hydrogen between galaxies. Spectrometers unweave starlight into colors and reveal composition like detectives reading fingerprints. When we find a spectrum with telltale signatures, water, methane, oxygen, we do a kind of forensic archaeology across time and space. We cannot visit many of these places. Instead, we learn to translate the light they send, to read whispers of chemistry and motion, and to infer landscapes from small, indirect clues. There is also the poetry of scale in motion. Galaxies collide not as catastrophic bangs, but as slow, majestic ballets that stretch across millions of years. When 2 galaxies meet, their stars mostly pass like ghosts, but their gas clouds crash and ignite bursts of star formation, new lights born from the turbulence. In the far future, our Milky Way will kiss Andromeda in such a dance, a slow merging that will change the map of the night, but will not necessarily be an apocalypse for individual systems. Time grants the universe a kind of patience we cannot fully fathom. Let us touch, briefly, on endings and beginnings folded into one. Stars of certain masses end their lives with a final flourish. They swell into red giants and drop outer shells that smell of future gardens, planetary nebulae, whose glowing rings are nothing less than stellar farewell notes. Some massive stars go out as supernovae. They explode with a brightness that can outshine entire galaxies for a while, scattering heavy elements into the void. These explosions are fertile. They pepper the interstellar medium with the seeds for future planets and life. The iron in your blood was once inside a star that died in fire. And then there are rarer endpoints. Neutron stars compacted into the mass of the sun, but squeezed into a city-sized sphere. Spinning so fast, they sweep beams of radiation across space like distant lighthouses. When 2 neutron stars merge, they ring the cosmos in gravitational waves, ripples in space-time itself. These ripples are like the faint tremors of a gigantic bell, small on our scales but monumental on a cosmic ledger. We have learned to hear them, to listen to space-time. And in doing so, we have opened a new sense. Now imagine, for a slow moment, a distant sea, where bioluminescent organisms light up like stars in miniature. Each little flash a private signal, an invitation, a memory. On some exoplanets, life, if present, might glow under active skies, or it could be hidden within subsurface oceans under a frozen crust. Moons like Europa or Enceladus, in our own system, hide oceans beneath icy shells. There is something deeply consoling about water kept warm and dark for aeons, about the patient possibility contained in enclosed seas. If life exists elsewhere, perhaps it is quiet, tucked into corners where chemistry can be steady and undisturbed. Let your thoughts wander to civilizations, which may exist as brief candle flares along a long timeline. The technological curve of a species could rise quickly and fade due to self-made or natural disasters. It could also plateau into a sustainable, quiet stewardship. We do not know. We only know our own species' late curiosity and the sudden brightness of our signals leaking into space like dandelion seeds in a wind. Radio and light-based signals expand outward, thin and faint, like footprints in powder snow, detectable at a distance if someone is both listening and clever enough. There is comfort here too. Loneliness on cosmic scales does not mean emptiness. The cosmos is full of patient processes. Life and intelligence, if rare, may be spread like scattered campfires across an enormous plain. And perhaps the act of knowing, of looking, measuring, imagining, binds us into a community with the rest of the cosmos. In studying stars and particles, in parsing spectra, and building telescopes, we cast ourselves as students in a grand school. As you listen, either with your ears or with your mind, feel the rhythm of the universe as a lullaby of durations. A human lifetime is a handful of breaths compared to geological ages, and geological ages are a blink beside cosmic epochs. Yet within a single heartbeat, we can hold awe, grief, curiosity, and love. These human scales are not failures of perspective. They are the universe experiencing itself in a compact, fervent form. Now, imagine returning home, descending slowly from the bright cathedral of the galaxy, through the still, cold arms of interstellar space, past the commuter belts of comets, past the warm glow of a friendly star. You approach a tiny blue planet, the home you know. From orbit, continents are soft petals and storms curl like calligraphy. Cities are small nodes of light, patterns of habit and story woven together. On one such night, someone looks up with an ancient sort of yearning, recognizing in the dots above both estrangement and kinship. To end, consider this quiet, generous truth. You are made from the same elements as the stars, and those elements have traveled cosmic distances to arrive, patient as rain, into your bones. Your thoughts are shaped by molecules forged in fire. Your curiosity is a continuation, an echo of the processes that stoke stars and fold galaxies. In that sense, the cosmos is not merely something outside, it is an inheritance and a companion. So let tonight be ordinary and extraordinary at once. Let the soft knowledge of distant light settle in like warm dust. If sleep comes, let it be gentle, like the slow drift of an orbit. If your mind wanders, let it wander along the spiral arms, where new stars are still being hatched. Tomorrow, when you open your eyes, the world will feel familiar and newly strange, and you will carry with you the hush of long distances, the patient grammar of the universe, and finally, a closing image. A small child on the threshold of a house, holding a lantern. The child is not yet sure what stories will come, but they are learning to read the sky. The lantern casts a gentle circle of light, and, within it, the child's face is full of person-sized astonishment. Outside that circle unfolds a darkness so wide and generous that it invites stories rather than denies them. Walk now into that small, safe pool of light. Breathe, and let the vastness sing you slowly into rest. Good night. Hello, dreamers. Welcome back to Bedtime Universe. Lay your head down, breathe slowly, and let the room around you dissolve into a soft, velvety hush. Tonight I will tell you not one quiet tale, but many threads of human curiosity and cosmic mystery braided together like a slow, luminous rope that pulls us out beyond our familiar shore. These are stories that have traveled, in some form, from watchful telescopes and busy laboratories, from deserts, where astronauts learn to listen to the wind, from the clever hands of students sketching life support systems on napkins, and from the deep, patient light of newborn worlds. Each thread is a small miracle. Each breath you take now travels the same physics that carries starlight. Let us begin. Imagine a field of dust that is almost too fine to notice, a gossamer of grains smaller than a fingernail, circling a young star. For eons, the dust whirls in slow, patient currents, colliding, sticking, growing. Sometimes those grains gather into pebbles, then into rocks, then into something with gravity, with a faint warmth, with a tiny, greedy appetite for more. In the glow of distant instruments, we have not just imagined, but watched this process in motion. Recently, the human eye in space, the James Webb Space Telescope, trained its golden gaze on a massive planet, encircled by a disk of dust and gas, and found evidence that within that ring, the raw chemistry to build moons is present. It is the very stuff of small worlds, hydrocarbons and carbon dioxide, the whisper of molecules that, over cosmic time, might clump and spin into moons of ice and rock. We are watching, in a way that would have seemed magical to earlier generations, a construction site for moons around a faraway planet named CT-CHAB, some 625 light-years from our own sea of blue and green. Now let that image fold into another. Picture a planet so recently formed that it still glows with the heat of its own birth. Imagine light wrapped around it like a shawl, a fragile violet halo in the cold dark. Astronomers have been lucky enough to capture direct images of such newborn worlds. These are not the distant, cold rocks that circle in silence around our own Sunday. These are infant giants, flecked with warm light, waltzing within the very rings that made them. One of these discoveries was announced with the wonder of a discovery alert. A baby planet photographed in a ring around a star. A minute, hopeful glow that tells us the universe is still busy making itself. The tidings came from careful telescopes and patient analysis, and they remind us that creation is not only in the past. Creation keeps happening, now, elsewhere, as you listen to this story. From the quiet work of the universe, we return our gaze, gently, to the busy, tender work we do for ourselves. In Houston at Johnson Space Center, there are new faces now learning how to be guardians of our ventures beyond the air. A new class of astronaut candidates has been welcomed, 10 in number, each chosen for a life devoted to training, to study, to listening. They learn to move without gravity, to care for each other in small, crucial ways, to swim through simulators that mimic a world with no flaw. They learn wilderness survival, so that, if the unexpected comes, they may adapt with calm and skill. Think of them standing at dusk, tied to suits that smell faintly of rubber and new fabric, watching the same moon you watch from your window. They carry not only their own hopes, but 1,000 small ambitions of engineers who made their rockets lighter, of teachers who once read them stories about the stars, of communities that believe in possibility, and yet, selection alone does not put humans back on the moon. There is a kind of gentle insistence in laboratories and university classrooms everywhere. Teams of learners and dreamers, building things that could one day become lifeways on other worlds. NASA's Human Lander Challenge stands like an open door. It invites students and innovators to propose life support systems, to imagine how a group of people might live and breathe and sleep in a place that has no atmosphere to hold them. The call is practical, and it is poetic. It says, "Help us build homes of air and warmth for people who have not yet set foot on the lunar dust." It asks for pipes and filters, for ways to manage heat and the cold, to scrub carbon and carry water where there was none. It is a challenge and an invitation to stitch human ingenuity into the cloth of exploration. The design sketches and late-night cups of coffee that form in response are as much a part of human exploration as rockets and telescopes. Now, allow the story to drift a little further outward until the dark is not empty, but full of steady points of light, each a story. The James Webb Space Telescope has been mapping more than single planets and disks. It has turned its instruments toward great nurseries of stars, places where clouds of gas and dust coalesce under gravity's patient pull to ignite the first clear flame of a new star. In a region called Pismis 24, Webb has taken a sparkling image of star birth, a tapestry of orange and near-infrared light that shows clumps of matter arranging themselves into tomorrow's suns. Each such image is an atlas of origin, a quiet ledger of the ways matter organizes and becomes luminous, a reminder that even violent births can be beautiful. The telescope's images are not just pretty pictures to hang in a gallery. They are evidence, data, that allow scientists to ask how galaxies are built, how thick stellar disks form, how environments shape evolution. In these portraits of birth, we can almost hear the slow exhale of the universe as new heat begins to beat. The human stories loop back and forth with these cosmic events. Students building lander prototypes imagine future astronauts walking across regolith stirred by engine plumes. Engineers who study particle physics design shielding to keep that astronaut's heart beating steady against invisible rain. Flights take to our own atmosphere to measure the air we breathe, with scientific instruments tucked into aircraft to sample tiny particles and trace gases. The same curiosity that has us peering at newborn planets also leads us to measure the breath around our cities and the flow of water after a fire. The data that orbiting satellites send down help protect the people on a hillside downstream from a burned watershed. Science is a conversation between distant glories and immediate care between the stars and the soil. Imagine a lab at night, the lights low, screens glowing like constellations. A team of scientists studies spectral lines, thin patterns of light that reveal the chemistry of a planet-forming disk. The patterns tell of hydrocarbons and simple organics, the building blocks of complexity. Elsewhere, a group of students assembles a prototype for transferring fluid without losing heat. A little farther on, an astronaut in training slides out of a simulator and rubs her hands together, thinking not of the instruments she will one day use, but of the person who will rely on her care in the small hours of an alien night. The tether that binds these moments is responsibility. Each discovery is met with the question, how do we make this knowledge useful? How do we keep people safe while they explore? Let us drift now past formalities and into a simpler human moment. Picture a child somewhere on Earth, wrapped in a blanket and gazing at a tiny LED projector on the ceiling that shows slow, twinkling stars. Perhaps she has heard of the Webb telescope's images. Perhaps she has read a small headline about a planet being photographed in a ring around a star. In that child's small mind, the universe becomes an immediate companion, a place of friends waiting to be met. That is the true power of what we do when we send telescopes into the dark. We give the next generation an expanded map of what is possible. You might imagine that space agencies and large telescopes are remote, their work cold and technical. But the truth is softer and stranger. It is a story of many hands, of late-night code that finally runs, of metal surfaces polished by apprentices, of teachers who press a paper telescope into the hands of a child. When Webb returned images of star formation, people anywhere with an internet connection could pull those images like a blanket over their lap and study them. The images cause wonder precisely because they connect the very small with the very large, the grain of dust to the gleam of a newborn Sunday. Think now about silence in space, where sound cannot travel the way it does on Earth. In the quiet between stars, telescopes listen in other ways. They read the fingerprints of light. They read shadows and cooling curves and the faint warmth of gas. The story of CT B and its moon-forming disk was written in such fingerprints. It required patient observation and careful analysis. It is also a story that tells us something about the potential for complexity in other systems. It says that the processes that once formed our moon or shaped our planet are not unique. Elsewhere, in a dark ring around a young planet, dust and molecules dance out the recipe for new satellites, miniature stages where future geology and perhaps future chemistry will play out. Our world, meanwhile, keeps asking to be protected. NASA's instruments that roam the skies help scientists map how fires alter water supplies, how dust moves after an engine plume, how particles travel through our air. That knowledge helps a farmer know when to plant, helps a town understand the safety of its reservoirs, helps an emergency team decide where to put sandbags. The same curiosity that reads starlight becomes a tool of care on Earth. Now allow the narrative to fold in one more theme, the idea of apprenticeship and challenge. Challenges like the Human Lander Challenge are not only contests, they are classrooms with very public finals. They ask people to imagine the improbable and then make it real enough to test, to prototype, to fail, and to learn. Think of student teams whose hands are inked with schematics and whose whiteboards are full of scribbled equations. They are the ones who will iterate through failure to find something that works in the harsh vacuum and abrasive dust of the moon. Prizes and challenges push ideas forward, not by fiat but by curiosity. As your breathing slows, imagine a single small scene that gathers all these threads into one gentle image. A young engineer sits before a screen displaying a glowing ring around a planet. On his desk is a plastic model of a lander. On the shelf, a faded photograph of the Grand Canyon. Beside him is a calendar with the dates of a student challenge he hopes to enter. Outside the window, a plane traces invisible ribbons in the sky as it samples the atmosphere. He thinks, quietly, of the future. Of a person who will one day sleep under a thin dome on the moon, who will look up, not at clouds, but at a sky filled with Earth, and who will know that someone in a dusty lab once dreamed and sketched and kept going. He knows his work is small and essential. Stories like these are not all triumph. They are also full of patience and slow correction. Telescopes can mislead, and data can be ambiguous. Plans can be refined. What matters is the persistence of the people who care enough to examine the difficult parts and take the time to get them right. It is the same persistence that lets a child return to a puzzle until she understands it. It is the same quiet stubbornness that has led humans from carved stone to spacefaring craft. And now, for a last little voyage before sleep takes you. Imagine that the very dust that built those newborn planets someday seeded life elsewhere. Imagine also that our own small planet continues to require tending. The researchers who measure our air, the students writing code to manage life support, the dreamers drafting lander designs, the astronomers pointing Webb at a distant nursery. All are involved in a single, long labor of stewardship. The universe offers wonders without end. Our job is to learn how to reach them and how to live wisely beneath their glow. As your eyelids grow heavier, let the images settle like a soft film behind your eyes. See the golden honeycomb mirror of a great telescope, its facets catching faint infrared light. See the slow ring of dust around a distant planet, curled like a sleeping animal. See the new astronaut stepping out of a training pool, smiling at the absurdity and joy of it all. Hear, faintly, the hum of aeroplanes that check our air. Feel the gentle insistence of students and their challenges. Take one more long breath in now, and let it be full of stars and the cool chemistry of distant disks. Breathe out, releasing everything you have carried from the day. Lay your cares upon the pillow, and know for a quiet moment that human curiosity and careful tending continue all night and all day. People at observatories and centers of learning are awake in a different time zone, poring over small signals and long data sets. They will snooze, and they will wake, and they will continue the work that expands what we can imagine. Sleep now, explorer. Dream of moons being born in the lullabies of dust and light. Dream of engineers whose sketches become habitats. Dream of young astronauts who will one day float by a window that looks down on a sleeping Earth. When your eyes open again, the world will have spun a little further in its orbit, and perhaps a new image will have arrived to remind us that the cosmos is never finished telling its stories. Good night, from all of us here at Bedtime Universe.